Here is my take on 80s home computer magic. As a kid, I was blown away by pixel graphics and games like Space Invaders, an alien world and technology just waiting to be explored. That is why in this video series I present my dream home computer, the Minimal 64. To me, it's the most computer from the least logic, or the shortest path from TTL to Space Invaders. While having a working PCB version of a computer is a must for me, it's always nice to have an emulator at hand. I've already published a C++ version, but now you might ask, why another one in Java processing? Well, this one is super accessible, cross-platform, easy to understand and modify, and could really help you get the most out of a Minimal 64. Let's see how simple an instruction-level emulator can be. This means we are emulating only the end result of each instruction, not the microcode. So the only inner state we care about are two arrays for RAM and flash memory, the accumulator, the bank register, and the program counter, and that's all. If you are familiar with the Java processing environment, you'll know that every sketch has a draw function that per default is executed 60 times per second in order to ensure smooth animations. The emulator's draw function fits on a single page. We'll skip the boring keyboard and file input stuff for now and just focus on that function. At the beginning of each frame, we are granted a number of CPU clock cycles based on the frame's duration. Usually that's around 100,000 cycles. And for each instruction executed, a certain number of cycles is deducted from this number. The function doInstruction fetches and executes the next instruction at the program counter and returns the number of cycles used according to a lookup table. Once we've used up all our clock cycles, we update the video RAM output by creating a p-image and copying the content from RAM address hex C000 onwards into that image. We are grabbing a VRAM byte at a time, and for each of its bits we either write black or green color information into the p-image. Finally, we project the visible part of the VRAM without the blanking intervals onto the drawing canvas. Keep in mind that the Minimal 64's VGA circuit does not feature hardware blanking intervals, but relies on software to clear them. If you want to see the entire VRAM including its blanking intervals, you can just omit this get function here. But I think it looks better without them. The last line handles repeating keys, and that's it. You've probably noticed that all the heavy lifting is buried in the doInstruction function, so let's take a quick look. At the current program counter memory location, doInstruction fetches the instruction opcode and increments the program counter. What follows is just a giant switch statement that for each of the 128 instructions opcodes provides a code snippet simulating the action of that particular instruction. Let's look at the LDI or direct load instruction, for example. It simply reads a byte from the current program counter position and stores it in the accumulator. Done. Jump to address or GPA uses a takeAddress helper function to read the LSB and MSB of a 16-bit value from the program counter and stores it back in the program counter. Also simple. LDA or load from address fetches a 16-bit memory address and then loads the RAM content of that address into the accumulator, while STA for store at address fetches a 16-bit address and writes the content of the accumulator into that address. I am using the wrapper functions readmem and writemem here, rather than directly manipulating the RAM or flash arrays. As you can see, not every instruction looks so simple. Some of them involve updating the ALU flags, but you'll get the hang of it and can work your way through them one by one if you like. Let's click the play button and launch the emulator. The MinOS operating system I've demonstrated in my previous videos starts just like on real hardware. So let's revisit the VGA demo, for example. And now for some Space Invaders again. Okay, now that you've seen how straightforward and fun it is to work with the Minimal64 emulator in processing, I encourage you to give it a try yourself. Dive into the world of 80s home computer magic and explore the potential of the Minimal64 home computer that I've showcased in my earlier videos. Hopefully this emulator provides a good starting point for learning, experimenting and creating your own unique projects. Not only does it offer an accessible and cross-platform experience, but it also invites you to modify the code and make it your own. So go ahead, download the emulator and immerse yourself in the exciting world of retro computing. And as always, if you enjoyed this video and want to see more, don't forget to like, share and subscribe and hit the bell icon so you never miss an update. If you have any questions, feel free to leave a comment below. I'll do my best to help out. Happy coding and see you in the next video. Take care. Bye.